Bismillahirrahmanirrahim. Viewers, today we are going to discuss method for solving PDE by converting it into canonical form. Just to illustrate the method, we consider this partial differential equation and we solve it by converting it into canonical form. Look at the question: x square r plus 2xy s plus y square t is equal to 4x square. Here we have x and y independent variables, and what do r, s, t mean? Look at, if z is a dependent variable depending upon x, y, then notation is zx is pq, zy is zx is p, zy is q, z double x is equal to r, z xy is equal to s, and z double y is equal to t. These are standard notations which obviously mathematicians use. If z is dependent variable, then these notations are used, and if u is dependent variable, then obviously we will have ux is equal to p, uy is equal to q, u double x is equal to r, uxy is equal to s, and u double y is equal to t. These are the notations. Now, using these notations, we have x square r means z double x, plus 2xy zxy, r is replaced by z double x, s is replaced by zxy, plus y square, and t is replaced by z double y is equal to 4x square. This is our given partial differential equation. Using these notations, z double x for r, zxy for s, and z double y for t. Now look at this partial differential equation. This is second order partial differential equation with variable coefficients. Now why we say it with variable coefficients? Because the coefficients of the derivatives are variables. Look at here, z double x coefficient is x square, zxy is equal to, the coefficient of zxy is 2xy, and z double y's coefficient is y square. This kind of differential equation is known as partial differential equation with variable coefficients, and obviously this is of second order differential equation because highest order partial derivative involved in this equation is double derivative. That's why this is second order differential equation. Now first, before solving this differential equation, first I illustrate the method through the flow chart. Look at here, this is given PDE, and we have to solve this PDE, solution of this PDE. Now one way is that we could go direct from this box to this box. We could go direct from this box to this box. Going direct from this box to this box is that considering this partial differential equation and using some particular method to solve this partial differential equation, we get the solution without converting it into canonical form. What does mean going from this box to this box? Means we are solving partial differential equation directly without converting it into canonical form. But obviously here we have to convert it into canonical form before solving it. Now we will adopt this way. We first convert it into canonical form. And then we solve this canonical form. Solution of canonical form, and then we go back to the original solution. We are adopting this way, starting from this box which has original partial differential equation. We convert it into canonical form, Then we solve it, and then we backward convert into the original form of the solution of the differential equation. Now, how can we convert this into canonical form? In order to convert into canonical form, we need its classification. There are three kinds of partial differential equations: elliptic, parabolic, and hyperbolic. And nature of the partial differential equation depends upon the coefficients of double order partial derivatives. Now here the coefficient of z double x is considered as a is equal to x square. Coefficient of mixed order derivative is considered as 2b. Here 2b is equal to 2xy, means b is equal to xy, and coefficient of z double y is considered as c, which is y square. Now, as I earlier told you that the nature of this partial differential equation depends upon the coefficients a, b, c, and we will consider here discriminant b square minus ac, means x y square minus a x square into c y square. This will give you x square y square minus x square y square is equal to 0. Now when we get b square minus ac is equal to 0, then original differential equation is parabolic. This shows that one is parabolic equation. It is necessary to determine the nature of the partial differential equation before it converting into canonical form, because there are three types and there are three different strategies to convert the partial differential equation into canonical form. Therefore, it is essential to classify first before solving. Now, if b square minus ac could greater than 0, it would be the hyperbolic equation, and if it is less than 0, it will be elliptic equation. Now here the case is that this differential equation is parabolic. Now once we get the differential equation once we classified the differential equation, then for this case we consider dy by dx is equal to b over a. For parabolic case we consider dy by dx is equal to b over a. Now put the values here. What is b? B is xy, and what is a? X square, and this will give you y over x. First step is the classification, whether the given partial differential equation is parabolic, elliptic, hyperbolic. After that classification, because this is parabolic, then for parabolic case we consider dy by dx is equal to b over a. Now we have to integrate it, and we have to find the solution of this dy by dx, which I am going to do here. Dy by dx is equal to y over x. Separating the variables, dy over y is equal to dx over x, and when we integrate it, it will be log y is equal to log x and one constant of integration log c. This will give you log y over x is equal to log c1, and taking anti-log on both sides we will have y over x is equal to c1. Next step is this c1 constant is considered another variable. Let xi be equal to y over x. As a case of parabolic equation, we get only one value of dy by dx, and therefore solving that dy by dx we get this xi. Xi is replaced by c1. Xi is replaced c1, or you can say c1 is replaced by xi, and we have another variable xi which is y over x. We need one more variable, but here we had dy by dx, the only one value of dy by dx. Therefore the second variable eta we will assume eta is equal to x. We assume eta is equal to x. Then we need here xix, which will be minus y over x square, minus y over x square, and xi double x will be equal to 2y over x cube. Similarly, xi y will be 1 over x, and xi double y will be equal to 0, and xi x y be equal to xi x is this minus y over x square, and its derivative will be minus 1 over x square. And calculate these things very carefully. Here we have the simple case eta x is equal to 1, eta double x is equal to 0, eta y is equal to 0, eta double y is equal to 0, and eta xy is equal to 0. We need these values, therefore I am going to calculate these values here. Now we have to convert this second order partial derivative, which is a function of xy, we are going to convert it into function of xi eta. Why? Because we have basically considered xi and eta other variables, and considering this, if z was the function of xy, basically z was the function of xy in this partial differential equation, introducing two other variables, this z becomes the function of xi and eta. Therefore, it is necessary to convert these partial derivatives as the function of xi and eta. Look at here, how can we convert it into zx. Zx means we are going to take its partial derivative with respect to x of z, but we cannot take its partial derivative with respect to x because z is a function of xi eta. Therefore, we have to apply the chain rule. We have to take the derivative of z with respect to xi, and then in order to compensate it, we will have partial xi over partial x, then partial z over partial eta, and partial eta over partial x. In very short, we can write it as z xi, and this will be xi x, this will be z eta and eta x. Here we had applied the chain rule. We, instead of taking partial derivative of z with respect to x, we are going to take its partial derivative with respect to xi, and compensating, take the partial derivative of xi with respect to x. Similarly, take its partial derivative with respect to eta, and compensating, take the partial derivative of eta with respect to x. And in elegant way, we can write it as xi x z xi plus eta x z eta. Similarly, when you take its partial derivative with respect to y, then what will happen? Before taking its partial derivative with respect to y, look what will happen if we take its partial derivative with respect to x. Means we are going to take partial derivative of zx with respect to x. Z double x means you are going to take partial derivative of zx with respect to x. Once again, this zx is a function of xi and eta. What will happen? We have to take its partial derivative of xi x z eta eta x xi x z xi plus eta x z eta, because we have calculated zx as xi x z xi plus eta x z eta. Now what will happen? We will take it partial over partial x of xi x z xi plus partial over partial x of eta x z eta. Once again, we have to apply the product rule here. What we can do here, keep xi x as it is and take the derivative of z xi. Then keep z xi as it is and take the derivative of xi x. Likewise, first keep eta x as it is and take the derivative of z eta with respect to x, and then keep z eta as it is and take the partial derivative of eta x. Now, once again, this will become xi x, and here once again we have to apply the chain rule. What is that? Partial over partial xi z xi and partial xi over partial x. Then partial over partial eta of z xi and partial eta over partial x. This is the simplification of this. When we are taking its partial derivative with respect to x, then we have to apply the chain rule, and this will give you this result. And here we will not apply the chain rule because xi is already function of xy, and you can take its partial derivative xi, then this will become xi double x. This will become xi double x z xi. Similarly, here keeping eta x as it is and once again applying the chain rule on z eta, we will have partial over partial eta of z eta, and then first of all partial over partial xi of z eta, and in order to balance it, partial xi over partial x. Similarly, partial over partial eta of z eta, and in order to balance it, partial eta over partial x. And this is what we could do here, applying the chain rule on z eta. Take its partial derivative with respect to xi and partial derivative of xi with respect to x. Take its partial derivative with respect to eta and partial derivative of eta with respect to x. Then finally, eta is also a function of x, and its partial derivative with respect to x can be taken directly, which will be eta double x z eta. These are the 6 terms of z double x, and if we simplify these 6 terms, then we will have, first of all, I write here z double x. I don't need to write z x here. Why? Because in equation number 1, I need just to put the values of z double x, z xy, z double y. Although it is necessary to calculate zx for calculating z double x, we have calculated zx here, and with the help of this zx, we have calculated z double x, but there is no need to write here on in our steps. But obviously, when you are going to solve the paper, then you have to write all these values, because you have to use these values again and again. Therefore, I am not writing this zx value. I am going to write direct value z double x. What is z double x? Look at here. Z double x becomes, this is partial xi or partial x, and this is xi x. Means this will become xi double x, xi x square. This will become xi x square. This partial xi or partial x means xi x, and this is xi x. This will become xi x square, and this will become z double xi. This will become z double xi. Once again, here this is eta x and this is xi x. This will become plus xi x eta x, xi x into eta x, and this will become z xi eta. And one term we will once again we will have another term from here. Look at here, this is xi x and this is eta x, and this is z xi eta, z eta xi. We are considering here z xi eta is equal to z eta xi, z eta xi. Therefore, getting this term, we can multiply this term by 2, and we will have here 2 xi x eta x into z xi. Then this term will be, this is eta x, this is eta x, this will become eta x square, and we will have here plus eta x a square plus z double eta. Eta x, eta x, eta x square, and this z double eta. And then xi double x plus xi double s z xi plus eta double x z eta. I think it's clear now. Xi x square z double xi plus 2 xi x eta x z xi eta plus eta x square z double eta plus xi double x z xi plus eta double x z eta. Now we use these values which we already have calculated here. This will give you z double x is equal to, what is the value of xi x? This is minus y over x square. This will give you y square over x4 z double xi, and then plus 2. Look, I work here 2 into xi x minus y over x square, 2 into xi x plus into eta x. I think eta x is equal to 1. Therefore, this will give you minus 2y over x square. This term will become minus 2y over x square z xi eta. Please look the steps carefully. Here we have 2 xi x eta x, 2 xi x, the value of xi x is minus y over x square, and the value of eta x is 1. Therefore, this will give you minus 2y over x square z xi eta. And finally, eta x is 1. Therefore, this will become z double eta. And obviously, second order derivatives are all 0. Therefore, this will be 0 and this will be 0. We name it as equation number 2. Now, considering this calculation z double x, the calculation of z double x, and obtaining this value of z double x, what do you suggest? What will be the value of z double y? Can you suggest the value of z double y? Obviously, just x is replaced by, x will be replaced by y throughout the equation. Then we can have, there is no need to calculate it. Similarly, we can write z double y is equal to, z double y is equal to xi y square z double xi plus 2 xi y eta y z xi eta plus eta y square z double eta plus xi double y z xi plus eta double y z eta. It is just the this equation is just obtained from this equation. There is no need to calculate it. There is no need to adopt these steps to find this equation. Now just we have to insert the values here. What are the values? Z double y is equal to, what is eta y? Eta y is 1 over x. This will give you 1 over x square z double xi. And here eta y, once again eta y is 1 over x, and xi y is 1 over x, and eta y 0. Look at here, eta y 0, therefore this term will become 0. And obviously this term will also become 0, and other term will also become 0. And here we will have z double y is equal to from here we will get z, from here we will get z double y is equal to 1 over x square z double xi, and this is equation number 3. Now what we need here, we need zxy. Now how can we get zxy? Once again I repeat the steps here just to get the zxy. We have zx here, and in order to get zxy, we have to take its derivative with respect to y. This is zxy means we have to take the partial derivative of which expression? This one, xix zxi plus eta x z eta. The value of zx is this, xix zxi plus eta x z eta, and we are going to take its partial derivative with respect to y in order to get zxy. In order to get zxy, we have to take the partial derivative of zx with respect to y. This is zx, and we are taking its partial derivative with respect to y. Once again, partial over partial y, xix zxi plus partial over partial y, eta x z eta. Once again, here we have to apply the product rule. Keep xix as it is and apply the chain rule on zxi. With this will be partial over partial xi zxi plus partial over partial y, partial xi over partial or partial xi of zxi, and then in order to compensate it, you will have xi y. Then partial over partial eta of zxi, and in order to compensate, you have to take the partial derivative of eta with respect to y. In this case, keeping xix as it is and taking its partial derivative with respect to y, by applying the chain rule we get this thing. Now keep zxi as it is, and take its partial derivative with respect to y. This will give you xi xy. Now repeat these steps over here. Keep eta x. Once again we have to apply the product rule here. In applying the product rule, keep eta x as it is and take its derivative with respect to y. Once again applying the chain rule, partial over partial xi of z eta, and this will give you xi y plus partial over partial eta of z eta, and this will give you eta y. And finally, look at here, keep z eta as it is and take its derivative with respect to y. This will give you z eta and eta xy. Now simplifying it, eta x eta y, this will give you xi x, xi y, and this is z double xi. This will give you xi x eta y, plus xi x eta y, and here we have xi y eta x plus xi y eta x, and take the common z xi eta. From here we get z xi eta, and from here we get z eta xi, but those two are considered as same, therefore we will have this thing. And what is next term here? Next is eta x eta y and z double eta. From where it is obtained? This is obtained from here, eta x eta y into z double eta, and finally we have plus xi xy z xi plus eta xy z eta. Now I am going to write this value here. Zxy is equal to xi x xi y z double xi plus xi x eta y plus xi y eta x z xi eta and plus eta x eta y z double eta, and finally these two terms xi xy z xi plus eta xy z eta. And once again we have to insert the values of xi x xi y and etc. What is the value of xi x? What is the value of xi x? Minus y over x square. And what is the value of xi y? This will minus y over x cube. Am I right? Z double xi. From here eta y is equal to 0. Therefore this will comfort us. Xi what is this xi? It should be xi y. Now xi y is 1 over x and eta x is equal to 1. 1 over x z xi eta. And here we have once again eta y, which will give us 0. And here second order mixed derivatives, these will give us 0 answer. Now putting these values from equation number 2, 3 and 4 in 1, we have putting these values from 2, 3, 4 in 1, we have now look at the equation number 1. Equation number 1, once again look at the equation number 1. X square and z double x. What is the value of z double x? Y square over x 4, then z double xi, shabash, minus 2y over x square z xi eta plus z double eta. And this was the value of z double x, and obviously we have to insert here the value of zxy as well, 2xy, and the value of zxy is what? Minus y over x cube z double xi plus 1 over x z xi eta, then plus y square, and here we have to put the value of z double y. What is the value of z double y? Here 1 over x square z double xi complete, and on the right hand side we have 4x square. Now keep the coefficients of z double xi. From here we have y square over x square, and take here z double xi. Another term is here z double xi. Here would have a negative sign or not? Z double xi, and in z double x xi x square. And obviously this is the coefficient of z double xi from this, and here we once again we have the coefficient of z double xi from this term. This will give you minus 2x minus 2y square over x square, and finally here we have y square over x square, and these are the coefficients of z double xi which I together here. Next keep the write the coefficient of z xi eta. From the first term we have here minus 2y shabash, and z xi eta. Anywhere else here this will also give you 2y. Is it clear? Z xi eta. And finally we have the coefficient of z double eta. This will give you x square z double eta, x square z double eta, and is equal to 4x square. Finally these terms will be cancelled out, this will also be cancelled out, and from here we have x square z double eta is equal to 4x square, or z double eta is equal to 4. This is the canonical form of the original differential equation. If examiner asks you to just to convert the differential equation into canonical form, then this is our answer. Now what we have done so far, we have started from this box where this partial differential equation was given to you, and instead of solving this differential equation directly, we convert into canonical form, and we are now here in this box. This is the canonical form of the original differential equation. Now I ask a question to you. What is the difference between original differential equation, this one, and what is the difference between original differential equation and its canonical form? Can you answer this question? What's the difference between original differential equation and its canonical form? Look at here. This is very difficult differential equation. This is second order differential equation. This involves second order derivative with respect to x, with respect to y, and mixed derivative. And one factor which makes it more difficult is that this is differential equation with variable coefficients, because the coefficients of the derivatives are variables. And look at here, this is so simple. This is so simple. This differential equation is second order differential equation, and this differential equation is differential equation with constant coefficients, because there is no variable as a coefficient of derivative, and this is very simple to solve it. How can we solve it? Just we have to integrate it twice with respect to eta, which we could not do here. Okay, once again, when you integrate it with respect to eta, what will happen? This will be 4 eta, and we will have another function which may be function of xi. I have already told you, when you partial integrate with respect to some one variable, then the constant of integration may be the function of other variable. Originally z is the function of two variables, xi and eta. When you are taking its partial derivative with respect to eta, then constant of integration may be function of another variable which is xi. Now once again we have to integrate it. We will have z is equal to, this will be 4 eta square over 2, and obviously here we will have eta phi xi, and once again we will have another function of xi. This will be another function of xi. Finally, we write it as z is equal to f of xi plus eta. uh, we can write it as g function of xi. Although there was no problem in writing phi 1, but we can write here in order to get symmetry g xi g of eta into g of xi plus 2 eta square. Now we have to remove the we started from this box where we had the original differential equation. We convert it to canonical form and get in this box, and then we solve it. This is the solution of the canonical form. Last step. What is the last step? We are going to backward. What can we do here? Just reverse the variables. Xi is equal to y over x and eta is equal to x. Just reverse the variables. You will get z is equal to f of y over x plus x g of y over x plus 2x square. This is the required solution of this differential equation. In order to solve this differential equation, we have adopted this flowchart form. Flowchart, we started from the original differential equation, converted into canonical form, then solving this canonical form and got the solution of the canonical form, and then by backward substitution we got the solution of the original differential equation. Hopefully you understand the method.